Derivative test. I'll try to give you tons of practice history. We'll see how it goes. What's the first thing I got to do?
Find the derivative.
Find the derivative. So f prime is 3x squared plus 6x minus 9. Now what do?
Set it equal to 0.
Set it equal to 0. 3x squared plus 2x minus 3 equals 0. How does it factor? X plus 3 or minus 3?
Plus 3.
Plus 3 and x
Minus 1.
giving you zeros of 1 and negative 3. Right now, that already has meaning. The derivative is 0 at those places. What's going on graphically? It's flat, exactly. There's a flat spot. Those are horizontal tangents. Have both of those things going through your mind. Horizontal tangents, the fancy thing you'd hear on an AP test, but flat makes sense to me. All right, so now that I know where it's flat, or the slope is 0, now what do?
Make a chart.
Make a chart, a sign test, the derivative. And I'm also, for the time being, going to connect that to what f is doing at the same time, though eventually you won't do the f part of it, you'll just do the f prime part of it. But right now I'm going to do both. We know that the derivative is 0 there, and as Harrison said, that means the graph goes flat, or there's a horizontal tangent at those places. Do you follow?
Yep.
Cool. What about left of 0, negative 3, excuse me, what is the derivative sign?
Positive.
Positive, which implies the function is?
Increasing.
Increasing. So increasing till it goes flat. Between negative 3 and 1, what's the sign of the derivative?
Negative.
Negative. If the derivative is negative, that implies the function is?
Decreasing.
Decreasing until 1 when the graph goes flat, and then the sign of the derivative after 1. Positive, implying the function is? Increasing. And so, for the time being, you'll be doing this kind of problem on polynomials. Polynomials, you know what the graph should look like. So this should confirm what you know. Does that look like an x cubed graph? Yeah, all right. Now it's important that you get this skill rock solid, because soon you're going to be asked to find the relative extrema of things you have no idea what the graph looks like. You can say you're flying blind. You have no idea what the graph looks like. You don't have this as a backup. Your calculus will have to be 100% rock solid, because that's where you're going to make all your conclusions from. Is all your calculus is going to do all the time. So this is a nice check, but that's definitely not your primary source. The calculus is what you have to master. You with me?
Yep.
Okay, cool. Now our conclusions. Is it okay then to say max at negative 3?
No.
Yeah, it depends on if you want to do all that work for no pay. It's like when you go to work all day and then you forget to punch in, you get 0 pay.
Oh.
Same goes here. If you do all that work and you write the conclusion that way, you get 0 points for that problem. None. That is not the conclusion. The conclusion is a sentence. Say the sentence for me, please. F has a
Max at x equals 3 because f prime changes from.
You could say goes or changes both, either one, from positive to negative. Perfect. All right, negative 3, not 3. I wrote negative 3. And the other conclusion is that f has a min.
X equals 1.
X equal 1 because
f prime changes from a negative to positive.
okay, that is the first derivative test. And is it going okay?
Yep.
Cool. All right. So, in terms of the homework tonight, I taught 33 and did notes on 33 yesterday, so there's no lessons here. The set 33 should be good to go on every problem, right? The meat of this day is just kind of learn from the exercise. We have set 32, and I will take maybe 3 or 4 questions on set 32. I'm happy to do that. But on the fun sheet, you need to understand that some of these are chosen with the expectation that they're just going to be disastrous. They're going to be really hard, and I don't expect you to kill it. I expect you to wrestle and fail and get stronger as a result. So the front sheets are AP exercises that are deeper level thinking. Just exercise your brain, and gradually you'll find them a little easier and easier as we go, as you start to get into the state of mind. All right? So don't be discouraged if that was really hard for you. It's no problem. So questions on, let's go with 32 first. Do you have 32 questions? Did I put the replacement answers online on 32? Anybody check the website in this class? I know the other. Yeah, they were there. Okay, cool. So that said, my replacement answers to 32 were online on the website. That doesn't mean they make sense. You should know that just because you can follow what I did doesn't mean you can do it yourself, or that makes sense. So please do ask if you'd like more explanation. Anything you got on 32? 1? 22? What else? Did you say, oh, did you both say 22? 1, 22? 24? I'm sorry, what? 18? Okay. All right, we'll start with those 4, and if you want to add some. Cool. 1 was a humdinger, boy. That was rough. I gotta say, that required some heavy-duty lifting on your part. And the problem is that in the Saxon book, he doesn't teach a lesson on this. He just throws it on our whim. It's not like a certain problem you're going to master. It's just one type of problem-solving problem. So good call. The idea here then is the concept is really problem solving. So that's what I'm going to model. It said if the volume of a sphere doubles, what's the ratio of the surface area of the new to surface area of the old, if I recall, yeah? All right, so the first thing that I did is I said, okay, this is not like I have done this problem before and I have some kind of process that I just crank out. I have to kind of treat this from new. So when I do that, I start by saying, all right, what's the question? They want me to get the ratio of the new surface area to the old. Then I say you might do something like this in science. What am I given? Well, I know that the volume doubles so that the volume of the new is 2 times the volume of the old. And that's really all they gave me. So I thought, well, okay, well, does this get me to that? And the answer is no. There's no volume surface area equation I know of. But what do they both relate to in between? The radius. Okay, so I said, well, maybe if I could use this to get some kind of radius relationship, then maybe I could use that to get the surface area question. So that was my plan of attack. Before I don't just start writing stuff. As a math teacher, I haven't seen this problem. I just figured, all right, let's get a plan of attack and see if it works. And there is always some degree of trial and error. So here we go. The volume new to 2 times the volume old. Well, if I'm going to get the radius, maybe I should go from there to the formulas. So what's the formula for sphere volume? 4/3 pi r, so that would be pi r new cubed, and that's 2 times 4/3 pi r old cubed. Do you agree with that? Okay? What then? Make your life easy. One problem says, make your life easier. What can you do to make your life easier? Yeah, don't put the 4/3 pi. That seems like radius new cubed is 2 times radius old cubed. That's a heck of a lot better. Let's keep going, not to radius new, but just straight up, or cubed, but straight up radius new. What's then radius new's relationship to radius old? The cube root of 2 times as big as the old radius, but when I cube root it, it's just radius old, yeah? You with me?
Yes.
All right, so now I have a radius relationship. That's cool. Now let's talk the surface area question. I don't want an equation like I did here. It seems like they want it in ratio form. Okay, so surface area new to surface area old. What now? Formulas, yeah. 4 pi r new squared is to 4 pi r old squared. Cool. What now? Yeah, divide out the 4 pi's, that's a lot easier. Radius new to radius old. I'd like to cancel out those squares, but I don't think I can do that. All right, now what?
Plug in.
Yeah, plug in that fact. You know that the radius new, which you still have to square, is root 2 times as much as the old radius. Well, if you do that, the radius old squareds drop out, and it's just a ratio of the surface area. The surface area is 2 to the, what power? 3 halves or 2/3? 2 to the 2/3 times as big as what it was. That's a little more than, actually, I don't even know. What is that? 4 cubed root of 4, probably 1.2-ish times as big. I don't know. Does that make sense? Okay. So, yeah, that's some hard thinking, but you'll get better and better at that. 22, is that a replacement or a normal book problem?
Normal.
Okay, so number 22 is, oh man, I'm a little rusty on the old identities. But luckily, I don't rely on memory, I rely on understanding, so it'll come back to me. Here we go, cosine of 5/2 minus a times the cosine of a. And they told you earlier that in the previous problem, the sine of a is 1/3, and a is in the first quadrant. Okay, cool. So what does this equal? And they give you that fact. All right, so sine of negative a, what is it equal to? Negative sine a, why? Okay, a is an angle, right?
Yeah.
So if a is an angle, then the opposite to hypotenuse ratio would be up here, yay? Well, what if you did negative a then? What does a negative angle mean? It means you go down. Now, if you go down, doesn't that mean you get the opposite y side? And so you get the same ratio of opposite to hypotenuse, but it's with the negative, so it's negative of the normal sign in the first quadrant. It's a -1. All right? Cosine of pi over 2 minus a. What the heck does that mean? It's sine. Why? Okay, so think of it like this. Here's pi. I'm going to call this angle A, and this pi over 2 minus a. You follow me? All right. Now, if I say that, and I'll call these sides A, B, and C. If I said, what's the cosine of pi over 2 minus a, what's the ratio? Cosine is, so ka to adjacent to hypotenuse. Cosine of pi over 2 minus a is A over C. Isn't that the same as the opposite of this angle, A over C? So cosine of the other angle, these are called cofunction identities. Cosine of the other angle is the same as the sine of the original angle in the triangle. So that's sine of it. Oui, oui. All right, and then cosine of A is cosine of A. Cool. What about negative sine A? Given that we know sine of A is 1/3, negative sine of A is negative 1/3. Sine of A is 1/3. The only gotcha left is cosine of A. Draw a triangle here. It says that this opposite to hypotenuse ratio is 1:3. And it's in the first quadrant. So if the opposite is 1, the hypotenuse is 3, what do I need for the cosine? What's so ka ho? So ka adjacent is root 8. Root 8, yeah? That's Pythagorean theorem. So what's ka? Cosine. over whatever that equals that change. Okay. Okie dokie. We're cool there. 24. Is that the one that I did not paste in, but it was a replacement problem? Isn't it? I don't remember what that was. You didn't ask about 20? Wow. You guys are good. I thought 20 was hard. 24. 24. All right, whatever. Okay, so 24, kind of weird. This is called analytical geometry. It's the idea of geometry placed on the coordinate plane. So it's an algebra geometry mixture. What is it? AA? AA. Okay, so what is the slope of this line? What is M1? M1 is rise over run. A over run. A. So the slope is 1. Cool. How about this slope? M2. Now this goes from 0A to A0. So M2, what's the rise? A, positive or negative? Negative A. And what's the run? A. So the slope is -1. Then it says, what do you notice about those slopes? And then here's where you might make a mistake or not say enough. Is it true that they are opposites? Yes, but what they're really saying is the slopes are opposite reciprocals, which implies that the diagonals are, if two slopes are opposite reciprocals, then those lines are perpendicular. Okay. Or orthogonal in vectors. And orthogonal is one of my favorite words. All right, 18. Is 18 still a question? Just to fill the whole part. Okay, cool. So the part that always cooped me out is this seems so complicated, and yet the graph of that is really not that complicated if you consider that, yes, at -2, things get wacky. Is it a vertical asymptote or an x-intercept or something else? Something else. It's a hole, okay? But everywhere else besides the hole, so 0 over 0 is a I don't know what to do. But everything else is not an I don't know what to do. For example, at 1, it's 3 and 3, they cancel, and you're left with that. When x is 10, it's 12 and 12, they cancel, and you're left with that. So at every other x, isn't this the same as just 2x minus 4? And the only difference between that very simple equation and that equation is that this one has a hole down here at -2. And otherwise, they are exactly the same graph. Now the question to be then is, how do you make it continuous? Well, to make it continuous, you need to remove the discontinuity. So they call it a removable discontinuity. You're going to call f of x, oops, g of x, they said call it g of x. Well, for every pointer besides -2, I'm just going to use the function. So you can use 2x minus 4 if you, don't use 2x minus 4 if you want. Use the function, or you keep it back. At every point besides 2, there's no problem. The graph's fine everywhere else, so why change anything? Just keep it the same. But now, I think you'll agree that if I said, hey, is this continuous, the first thing you'd say, no, f at -2 isn't defined. It violates the very first step of continuity. The point isn't defined. So we need to address that issue. G of -2, I should have said G is -2, needs to be defined. I need to figure out where can I place a point so that it fills the hole. Don't we also know that G of -2 needs to equal what this guy is approaching? Okay? So what is this approaching? As x gets closer and closer to -2, the function is approaching -8. That means that I need to define a point that when x is -2, this should have said -2, when x is -2, put a single point at a y of -8 so that we fill the hole. And it's continuous. Right. So that's the idea. Now, you'd want to do that because then now you can do calculus on it. You can't take a derivative at a point that doesn't exist. So later on, then we'll say, okay, now our calculus is wrong. All right? Does that make sense? Cool. All righty then. Let's go to the fun sheet. I have the fun sheet key online, but that doesn't mean that you understand the thoughts behind it. So let me know which ones you'd like to talk through. 11. 13C. Cool. All righty. 11 and 13C. Let's see if you improved your mental strength through this exercise. All right, so you guys asked humdingers. That's for sure. 11. Oh, 11 is a tough one. All right. Some multiple choice questions on the AP test have averages like 18% of the people get them correct. Which is to say, in those questions, you actually would have done better just random guessing than trying to do the calculus. Not you, those people, not us. We will do better by doing the calculus. So this is, I don't know if it had that low an average, but this is a bit of a humdinger. This requires you to really stretch yourself. So I got a height equation, cool. What's the height of the object in meters at the instant it reaches its maximum upward velocity? So do I want to find a height or a time or a velocity? First thing, get it clear in your head what the heck you're trying to find. You're trying to find a height. You're trying to find a height. So the question is, what is the height when it reaches at the time it's at its max velocity? Not the time it's at its max height, the time when it's at its max velocity. So when it's going absolutely fastest, what's the height of it? Okay? Now, all right, cool. Now, students then, I would imagine the students I talked to yesterday, we said, all right, so I know that means I take the derivative, right? So -3t squared plus 12t plus 13. And they say, okay, now according to my notes, I then set that equal to 0. And they found a time. I don't know if that factor's clean. Does it factor clean? It doesn't factor clean. That's too bad. It would have been better if it factored clean. All right. Now, at that point, I can already, I'm sad for you because you're just wasting. If you do this, say you found some points and then you sign tested it. Say it came out clean and you found that H prime went positive to negative to positive. You follow me? Actually, probably go negative, positive. Anyway, what would that indicate here? If H prime went negative to positive, then what does that tell you? What? Minimum of what? Minimum of the height. So if H prime went negative to positive, isn't that a minimum height? Is that what they're asking for? Minimum height? No, they want a maximum velocity. Now you're finding the maximum velocity by finding not where H prime goes positive to negative, but where the derivative of velocity goes positive to negative. Okay, so H prime is great, but it's not the star of the show. Actually, I should have kept it. All right, negative 3t squared plus 12t plus 13. I want to know where v prime goes positive to negative. Well, what the heck? There isn't even a v equation in here. Big review time. What is velocity? It's change in position over time, yeah? Okay, and what are they calling position in this problem? Height, change in height over time. So, I ask you again, what is velocity? It's d h dt, or the derivative of the height, okay? So when I found h prime here, that's great. That is the velocity, right? Velocity is change in height with time, so it's the derivative of height. So you're doing well, you have the velocity, but I want to know where v prime goes positive to negative, so now what do I do? Take the derivative again. When I take the derivative of velocity, there's actually two things on either side of that. First of all, if I took the derivative of velocity, then isn't that the derivative of height, which means it's the second derivative of height? What is change in velocity over time? If you change your velocity, yeah, from 30 meters per second to 40 meters per second, you accelerate it. So you're actually finding the acceleration. Now, that said, find the acceleration. What is the derivative of velocity? Negative 6t plus 12. Now, that's what I want to find where it goes positive to negative. Now, I say, all right, what are the zeros, which in this case is at 2. I sign test not h prime, but v prime, because I want to know where v changes from increasing to decreasing. Before 2, like at 0, what's the velocity? Or sorry, v prime, excuse me, what's v prime? Positive or negative? Positive. Velocity is increasing. After time 2, time 72, time 100, big negative plus a little positive is negative. If v prime is negative, then that means it's changing in a negative way, which means v is decreasing. So did I find when the max velocity is? The max velocity is at t equal 2. You follow? Cool. Is that my answer then? Circle 2? No. What was I trying to find? The height when it's at its max velocity. So now, finally, I need to find the height at 2. When time 2 happens, what is the height at that point? So height at time 2 is, whatever it is, 42, I think. The original height equation. Yeah, and that's definitely going to make things hard because now you got 3 equations. You got equations all over the place. You got h prime, h double, h. You have to be clear to plug it into it. Okay. I wonder if it's in. No, 37, 35. Oh, they don't have the destructor that I would expect there. All right, at any rate, it's 42. You with me? That's a hard one. Okay, 13C. So, yeah, this definitely, so again, let me be very clear. The expectation is not mastery. The expectation is failure. I put this is an AP question from 2002. I put it on a DC homework, and I had maybe 3 people out of the class get it. It's freaking hard. All right? So, I didn't see, if you're thinking, you're such a jerk, you gave me this question and you thought it was failed? Well, yeah, exactly. It's like if I put you on a bench and put 400 on it, well, yeah, you're going to get crushed, but you're going to get some really good exercise trying to keep it from crushing you. You with me? That's what's going on here. Okay? So just fight the crush. All right, so this is the deal. In order to get to part C, I need to get through parts A and B. So let me catch up with you. And if you did not get A or B, then catch up with me. So the derivative is 3x squared plus 6x minus 45. When we find the critical numbers, we factor it. I think it goes something like plus 5 minus 3 in the factors. So the critical numbers are negative 5 and positive 3. Check me if you disagree. Oops, I don't need to do that. Okay, are we cool on A? I did a sign test then, and the shape does go something like this, which for a cube is what I would expect. You with me? All right. In part B then, in part B, they're not getting crazy on you. They're trying to ask you to do part B so that you even have a chance in part C. So in part B, when you have the max at x equal negative 5, they say, what's the y value at that point? Well, f at negative 5 is going to be what? Negative 125 plus 75, so that's negative 50. Plus 225, so 175 plus k. Is that right, anybody? Okay, cool. The min at x equal 3 is what? 54 minus 135, 1981, negative 81 plus k? So, this is where a picture is. So, this max, the point is, an x is negative 5, the y is 175 plus k, and the min is x is 3, y is negative 81 plus k. Alright, you tracking with me so far? Right now you might not know what the heck is going on, but do you agree k in essence affects the y-intercept and shifts it up and down? Okay? Are we cool? Alright, now let's draw a shape with a max at negative 5 and a min at 3. Let's say it looks like this. You down? You with me? Okay. Now, the question says, if f has 3 real roots, x cannot be too big or too small. To be fair to the BC kids, this I gave you tons of hints. They didn't hear this. They were flying by. Okay. X cannot be too big or too small, so the graph hits the x-axis 3 times. Would you agree that right now this has 1, 2, 3 roots? Okay. But if k was big and therefore had a really big y-intercept, then do you have 3 roots anymore? How many roots do you have now? 1. Now only 1 over here. Yeah. Likewise, k can't be too negative because then how many roots do you have? 1. And it's even possible that you could have 2 if it just barely skims 1, 2. So we want k to fall into the right region so that we're getting 1, 2, 3 roots. You understand the question? All right, now here's where you have to think deeply, all right? In order for you to have 3 roots, the max at x equal negative 5 must be where in relation to the x-axis? It has to be above the x-axis. Do you agree? Above the x-axis. Now that's where I started. Again, I want to emphasize that nobody knows where this is going. You just kind of start nibbling away, taking logical steps. Now let's take some logical steps from this. What is, so that's the max y when x is negative. That means the y must be, well, if it's above the x-axis, the y has to be, what? Positive. The y has to be positive. Well, what's the y at x equal negative 5? Part B? 175 plus k must be greater than 0, so k must be greater than negative 175. The y-intercept can't be too low, or else my root is ruined. So there's a bottom floor here where it can't get below that. That's what I just find. All right. Now with the same thinking, tell me about the other extreme. Instead of the max y at x equal negative 5, we need to talk about the min at x equal 3 must be below the x-axis, which implies that the y at 3 must be negative, which implies what? So what's the y at 3, or f at 3? Negative 81 plus k must be greater than 0? Less than 0, so k must be less than 81. So if I put those together, I can infer that k has to be between negative 175 and okay. Now, if you're thinking, man, there's no way I'm going to be able to do that by myself, you're probably right now. But please believe me, by the end of this year, that kind of depth of thinking you'll be able to do. And you'll be really amazed by yourself, because that's pretty freaking awesome. That's high-level thinking, and you're going to get there. It's really great. All right, 13C, cool. Anything else on 33-point sheet? There are some people that did not understand the graphing relationships, but it sounds like you did. Okay. Okay. I will be happy to walk around and help you individually. You have a good 14 minutes to work on tonight's homework. That's pretty rare, I gotta say. If you have a question on anything that's not going well, I still can't. I gotta say, I might be selling you short, but you didn't ask about this on set 32, and you didn't ask about it now. You're telling me you could do, the majority of you could do a 3-part product rule? You've never learned it. You got that?
No.
So why aren't you asking about it?
I'd like to do that.
Okay, so if you don't know, if you couldn't do it on your own, then you should ask about it. So I'm going to hold your hand a little bit, but in the future, if you don't ask about something like this, guess what's opening day quiz tomorrow? That, yeah, exactly. Because you need to be taught, I need to ask questions when I don't understand, all right? So I'm going to do a little holding your hand, and we're going to do 17, 13, I don't know what I was doing there, but that's not the problem. The problem is that you've got a 3-part product rule, okay? And you want to take the derivative on that, and I know the product rule, but what the heck when there's 3 factors? Well, the best way to work around that is to lump 2 of them together and call that first function, and call that second function. And again, there's one of these on set 32 as well. So make sure after this, maybe you can do that one well. All right, so if I do that, that's it. Somebody, Brian asked about this yesterday, so I guess I understand why he's not asking. Let's go. Product rule. First stays the same, so that's, what do I write?
E to the x.
X e to the x stays the same. Derivative of the second is? Okay. First part of the product rule done. Plus, second stays the same. What do I write? Cosine of x times the derivative of the first. Now, when you say derivative of the first, you think, oh, wait, I can't just take derivatives of these. That's a product. So now I need to do a product within a product. It's a nested product rule problem. So what's the product rule derivative on that? First stays the same.
1 times e to the x.
You do it opposite, but yeah, x e to the x plus 1 times e to the x, yeah? First stays the same, derivative of the second, plus second stays the same, derivative of the first. We? All right, that is done. You can call it good, but that's how you approach a product rule derivative with 3 parts to it. Lump 2 of them together and call it a first one. Right? Okay, doke. That's it. I will be happy to come around and help you individually. Let me stop.